You're in the water loop.
Welcome to Waterloop, the nonprofit news outlet exploring solutions for sustainability and equity in water. I'm the host, Travis Loop. Before we dive into the episode, I want to thank you, the audience, for making this platform possible. To support Waterloop, subscribe on YouTube, rate and review the podcast on Spotify and Apple, follow us on social media at The Waterloop, and sign up for email updates at waterloop.org. Thanks for being part of the conversation. Waterloop. Cities across the country are searching for ways to manage stormwater that are effective, space-conscious, and sustainable. One increasingly popular solution is deep infiltration, a practice that moves stormwater into native soils far below the surface to avoid harmful runoff and recharge groundwater. In this episode, Gregor Patsch of Oldcastle Infiltration explains how vertical drywells work, why they're different from injection wells, and how they're gaining traction with both local governments and developers. Before beginning the conversation, I want to take a moment to thank this episode's sponsor. Waterloop. Stormwater isn't just a problem to move away. It's an opportunity to put water back where it belongs. More and more communities are realizing that infiltration is a powerful tool for water resilience. That's why I'm glad to have Oldcastle Infiltration as the sponsor of this episode. Their Maxwell system is a vertical dry well that captures stormwater and sends it deep, up to 120 feet into native soils, helping to recharge groundwater. It also includes built-in pretreatment to remove pollutants before infiltration. You can explore how Maxwell works at oldcastleinfrastructure.com. Waterloop. Gregor, very excited to have a conversation about stormwater and some of the latest in stormwater with you. You know, it's not going to go away because it just keeps raining. So it's something to deal with. There's also a lot of new challenges out there with the intensity of rainfall and continued kind of development and pervious surfaces and impervious surfaces and all that stuff. So love to kind of get your take on an aspect of stormwater that I'm hearing about that I think you work on, and that's this deep infiltration. Right? Maybe you could talk a little bit about some of the different ways stormwater is managed and what this deep infiltration practice is.
Yeah, well, one of the big advantages of deep infiltration is that, and dry wells specifically, is its ability to reach multiple layers of native soils. So when we're infiltrating stormwater, we're trying to put stormwater back in the ground, right? So if you think about the way soil layers sort of form naturally, geologically speaking, there's multiple layers of soil. They have different compositions, and some of those layers are going to be able to infiltrate water really well, the sandy, gravelly stuff, the coarse stuff, and then some of them are going to be really poor at infiltration, like clays and silts. And so with a dry well, we're able to kind of, transect those layers perpendicularly and allow that water to find its way, find a pathway to those best layers. In comparison to other types of stormwater BMPs that do infiltration, let's take like an infiltration basin. It's really going to depend on that first layer of soil directly below that basin. That's going to determine its performance. Whereas with a dry well and a vertical system, we're going to be able to access those better layers and let the water find its own way most efficiently.
Okay, so you mentioned basins. You also have other kind of green infrastructure features like bioswales or rain gardens. All this stuff you're saying is kind of really just letting the water get into that very top layer, if it's even that permeable, right? This is like going down deeper, but not like injection necessarily wells. What's kind of the comparison or difference between those?
Yeah, that's a great question. So, we joke a lot about in our world here about dry wells, the term dry well, right? Because when you hear the term well, you're automatically thinking of a tube, a straw, whatever, that sort of connects from the surface directly down to groundwater and sucks the groundwater out, right? And then an injection well is sort of the opposite. It's I wouldn't call it it's not a stormwater infiltration BMP. It's that same straw, but it's just taking treated water, potable water really, and putting it right directly back into the groundwater. So, uh, dry well is really sort of a separate thing. It's not technically a well in that sense. There's no direct connection to groundwater. We're simply just bringing the stormwater into the native soils deeper, deeper below the surface, but still well above groundwater. It's a zone we call the Vados zone. Okay.
Ah, I love learning new words. That's one there for me. Could you say that again and even maybe spell it for me?
Yeah, Vados, Vadose. Again, think of a cross section we're looking at here where you've got your surface. Below that, you're going to have more of your topsoil with organics in it. Then below that, between the topsoil and the groundwater level, is a zone called the Vados zone. So those are native soils, and that's where a dry well is allowing the water to be introduced. And the key to that really is that, like I said, it's not a direct injection to groundwater. It's allowing those native soils in that vadosome to still filter out any pollutants or sediment that comes into stormwater. So it's
Wow.
still infiltrating through the native soils.
Okay, I'm getting a pretty good visualization here, but could you take me a little bit deeper into the design of one of these systems? I love your analogy of it being like a straw. I can visualize this cross section in my head with that straw coming down. But could you talk about that design a little bit more? You know, when you say deep, what does that mean? What does the structure look like underground? Yeah, take me into one of these.
Yeah, so we're often trying to bring engineers and contractors out in the field to take a look at these things because I think everyone who sees one in real life is amazed at the size of the scale of them. So we do 4 foot diameter or 6 foot diameter shaft that goes anywhere from 30 to 100 feet down into this Vados zone. It's a massive hole. That hole gets filled with gravel, right? And there's a pipe which introduces the water vertically into that gravel column. Gravel has a void space, right? All that storm water is allowed to fill into the void space of the gravel and then infiltrate into the native soils. And that concept's not new, right? Similar to like maybe a French drain or seepage pits or things where we've just had gravel under the ground that allows us to store water. What's different is that this is very deep, narrow, and that on the very top part, there's modern dry wells will have an integrated pretreatment chamber on the top, which is essentially a sump and some screens and filters because we want to keep that gravel pack as clean as possible. We don't want sediment, trash, cigarette butts, any of that stuff getting in that gravel. So we have a way to capture that at the top to be easily maintained and just let that gravel do its job, providing an underground reservoir really and allowing that water to soak into the soil.
So these deep infiltration, why is this a growing practice right now? Why is it becoming more popular? Usually, there's a lot of different drivers for things like this. What's going on out there?
Well, I think generally in the stormwater world, right, where we're trying to reduce the impacts of water running off of an urban landscape, right? The best way to do that is to not let the water run off at all, right? So it's this concept of stormwater capture and reuse. One of the ways you can do that would be sort of a cistern or a rain barrel, right? You're capturing that water and reusing it, not letting it off the site. Um, Infiltration in general and deep infiltration, again, we're trying to take that water that falls right on that site and give it a pathway to go back into the ground. And that prevents the water from carrying pollution off down to streams, flooding, creating erosion hazards downstream. So really treating it at the source. And so what we're seeing is more and more regulations are starting to favor within the hierarchy of stormwater treatment, infiltration is often being shown as the priority. So first, the first step is let's try to infiltrate this or capture and reuse it on site. If we can't do that, we can, look at filtering it and letting it leave the site.
Wow, interesting. So regulations maybe at like the local level from MS4 entities, other local governments, and so forth that are trying to deal with their kind of local water quality quantity issues.
Correct. Yeah,
Yeah.
it's a national issue or objective across the country, stemming from the Clean Water Act and the you know stormwater pollution plans, MS4 compliance, etc.
Yeah. So what kinds of like sites or conditions, locations fit for this? Like what's the ideal kind of scenarios where this is going to be effective?
Yeah, it's a good question. There's really sort of two such scenarios that come to mind with deep infiltration dry wells. The first one that I kind of alluded to before is, let's say you have a site and it's sitting on 10 or 20 feet of clay. Okay, and now clay does not infiltrate well at all.
Might as well be concrete in there, right?
Right,
Just like
right.
forget it. Yeah.
And then below the clay, let's say 20, 30 feet down, you have sand and gravel, right? So no type of surface BMP that's going to try to infiltrate the water is going to perform very well. But if we're able to sort of puncture through that clay, bypass that poor layer and get to the better layers, that's a that's an ideal scenario for dry wells. The other application, this is more of a real world application, is that we're seeing a lot of public projects doing a lot more dry wells within their Green Street initiatives within the public right of way. The reason for that is that, again, we talked about, the scale of this, a 6-foot diameter, 100-foot deep shaft, but on the surface, from a footprint standpoint, that's extremely small, right? So when you're out in these right of ways and you've got water lines and sewer lines and fiber optic lines, everything underground, there's not a lot of room to put stormwater BMP infrastructure. But so being able to actually drill in between and avoid these utilities is a huge advantage.
Hmm. Makes tons of sense. What about parts of the country? Whenever I'm learning about practices with water management, it seems that there's often certain places in the country maybe where things work better or where they're more popular. You've got different stormwater patterns, rain patterns across the country, different soil types, different topography, right? Lots of variety out there. Where in the country is these types of systems being put in, and why?
Yeah, that's a great question. We have been we've been installing dry wells for over 50 years. We started installing them. They really started in the Phoenix, Arizona area, where, as you mentioned, we've got great soils, really deep dry, really deep groundwater. And what's interesting is that time frame sort of predates a lot of the stormwater regulations. At the time, it was just the best way to get rid of this water. Like, where to get rid of it? Let's put it back in the ground. And so stormwater regulations have kind of caught up to this concept
Huh.
of infiltration, right? Um, we've moved into California, Southern California, great place for deep infiltration. Um, there's deep infiltration, dry wells going on in the Pacific Northwest. Um, Recently worked on a project in Michigan. So talked to folks on the East Coast. Dry wells, I always say that, they're not a silver bullet. Deep infiltration does not work everywhere if you have shallow groundwater or whatnot. But it's a specialized BMP that we want in our toolbox, right? And so Oldcastle makes every tool in that toolbox, and we're trying to just educate people on these dry wells, which I think is a little bit more of a unique tool. So it's going to work in certain places, certain little pockets around the nation and the world, really, but not everywhere.
Yeah, and a number of those places you mentioned are ones where, they really want water to stay local. If it comes out of the sky, they would love to get it down in the ground any which way they can, right? Rather than going downstream or just flash flood, go someplace else. Like they they want that water to get down in the ground somehow. Um,
Absolutely.
yeah. What about any examples of where you've done this work? Always looking at those kind of case studies and what the local need was and how it was designed and kind of what the results and benefits are. Any examples to share?
We do a lot of work with engineers working on private development, sort of low impact development, um, stormwater management, right? They're just trying to manage their stormwater on their site. They might not have a lot of room. They're looking at our small footprint. They like that. But one of the more exciting projects, in my opinion, I'll kind of call out the city of Los Angeles for some of their initiatives, which have been great. They had a large project called the San Fernando Valley Stormwater Capture Project. Now, the San Fernando Valley, known as the Valley, right? For folks who don't know, is it's naturally speaking, it is a enormous infiltration basin. It's just
Mm.
sandy soils, deep groundwater. Water comes out of the mountains into this flat valley and just soaks back into the ground. Um, but it's now currently completely paved over, right? The whole thing's concrete. So when it rains, all that water just flows out to sea. So the city of LA, with their Green Streets initiative, they're incorporating hundreds and hundreds of dry wells. And so what they're essentially doing is, they're puncturing holes through this whole San Fernando Valley, turning it into like a piece of Swiss cheese, if you will. And so when it rains and you get all that water has a place to go back underground, recharge groundwater, which they're planning to use in the future.
Mm.
The other important thing too about that is I think because that valley did drain so well, when it was developing, a few houses here and there, they didn't have gutters and storm drain infrastructure and all these things. And as it continued to grow out and build out, then there was nowhere to go. So they have like horrible flooding that goes on in that area. Um, and so the options for them were, you know, should we invest in all kinds of a water conveyance system, right? Large pipes and catch basins and all this infrastructure that they need to kind of get that water out of there. Well, they decided in a lot of cases they're going to just, put dry wells in strategically distributed and just let that water go back in the ground, much more cost effective way. So we're really proud of that project that we worked on. We think the city's doing a great job, and it's all part of their really bigger initiatives to be more sustainable and have their water locally sourced.
Huh. Interesting. It makes sense you connect it to that Southern California area. They are obviously water scarcity is a big deal. They're not looking for a silver bullet. They're looking for every little way that they can kind of capture water, right? Like locally
Right.
reuse water, whatever it is. So putting it back in the ground makes sense. Um, they also don't get rain frequently enough, right, to maybe merit some of those other pieces that you were talking about. It's kind of they'll get their storms or get their quick hits, but that's a way to capture it when those events do happen. Really
Right.
interesting. Yeah, and this connects to that kind of that broader groundwater conversation I just raised. That's a way, any way to get that water and keep it on site is key. Um, I'm always curious about the future. This is where I put the pressure on you to pull out a crystal ball a little bit, talk about what you see in the future for dry wells, deep infiltration. Like, where is this practice going?
Um, we've kind of we've kind of seen an evolution of stormwater management over the last few decades, right? Initially, stormwater management was really all about just conveyance. Let's get the water off the land, let's get it off the roads, public safety, right? Um, we got really good at that. As so, we ended up creating a lot of pollution and erosion downstream. So then kind of the next step of stormwater management was we started looking at how can we slow that water down? Let's clean it, right? And then we'll release it slowly to the streams and rivers, but it'll be cleaner. And so we kind of started to, shift mindsets there. And now the next really step in the evolution is like, well, maybe we shouldn't release it all. Let's try to capture it more and utilize it as a resource. And so what I see happening and where I see this all going is, historically there's sort of been these silos of drinking water supply, wastewater, stormwater, and they're all kind of looked at sort of separately. And what's beginning to happen and where I believe it's all going, we're starting to look at it much more holistically. Water is water, right? When it falls on the ground, we want to try and capture it, put it back in the ground. We can reuse it for drinking water in the future. And then further down the line, we're going to be recycling our wastewater more and more and putting it probably back into the system, potentially even through something like drywells.
Wow. So fascinating. I guess it just leaves me with a desire to see one of these. I guess you really only see them when they're being constructed, right? Like that's it. You dig the hole, people are putting the parts down there, assembling the thing, cap it off, and that's it. It's out of sight. I'll have to try to make plans to catch up with you and see one under construction at some point. But thank you so much for the conversation. Really informative.
Thank you. I appreciate it.
Waterloop.
Thanks again to this episode's sponsor, Oldcastle Infrastructure. Please learn more about them by visiting oldcastleinfrastructure.com.
Waterloop.
Thanks for listening. If you want to support Waterloop's ongoing exploration of water solutions, subscribe on YouTube, rate and review the podcast on Spotify and Apple, follow us on social media at The Waterloop, and sign up for email updates at waterloop.org. Until next time, be water, my friends.
You're in the Waterloop.